we're going to create a couple of vectors on the plane. The motivation behind it, in order to find the normal is perpendicular to any vector on the plane. So if we have, we're going to use this time the cross product. If we have two vectors, both lie on the plane, if we take the cross product, then we're going to find a vector that is orthogonal to both. And that vector will be orthogonal to the plane. So that's what we're going to do in this case. We have 3 points, so we're going to let the point PQ, and PQ equals to what? 3 minus 1 is 2, negative 1 minus 3 is negative 4, and 6 minus 2 is 4. And we also have the vector PR, so R minus P, 5 minus 1 is 4, 2 minus 3 is negative 1, and 0 minus 2 is negative 2. Okay? You'll have, like the equation of the line, equation of plane is not unique. A normal to the plane can point in one direction, can point in the opposite direction. So what happens if you do if we change the order for the cross product, which we're going to do next? Instead of multiplying, we do PQ cross PR, we do PR cross PQ. You'll end up having a normal in the opposite direction. Okay? But since N is perpendicular to both PQ and PR, then we can do the cross product. N will be PQ cross PR. And remember how we do the cross product. So and now, so what is the result? Well, the I component, negative 4 times negative 2, so we'll have 8 minus negative 4, so 8 plus 4 is 12i. Now, the j is negative, so instead of doing the major diagonal, instead of doing 2 times negative 2 minus 4 times 4, I'll do 4 times 4 minus 2 times negative 2. So 16 minus negative 4 will give me 20. See what I did? And k will be, of course, 2 times negative 1 minus negative 4 times 4. So we have negative 2 plus 16. So that will be plus 14k. So those are the direction numbers are 12, 20, and 14. Okay? So we're going to let a point, p sub 0. I can choose either point of the 3. I'll choose the first one to be the point 1, 3, 2, and we know that the direction vector let's write it properly. The normal n with direction numbers A, B, C, using vector component notation 12, 20, and 14. I don't know if you noticed, but 12, 20, 14, they all scale by a factor of 2. They all have common factor. So I can write it as 6, 10, and 7. It's the same vector. It's the same direction. So, and now I can finish this up by doing the following. So I'll do the scalar equation of the plane. So with all that, we have the first direction number is 6. So we'll have 6 times x minus the point is 1, 3, 2. So 6 times x minus 1. Can I undo the split? Anybody still using the split? Okay, I'll undo the split. So 6 times x minus 1, the second direction number will be 10. and the y value is 3, so, and finally the last direction number is 7, and I believe z is 2, so z sub 0 is 2. Okay, and all of it equal to 0, and now we can change that into a linear equation. So we have 6x plus 10y plus 7z, and let's see, we have negative 6 minus 30, so minus 36, minus 14, so minus 50 equals 0, or 6x plus 10y minus plus 7z, the 7 and z look alike, equal positive 50. Either solution is a good solution. Here I forgot to equal 0, so to equal. So 6x plus 10y plus 7z minus 50 equals 0, or this one.
Should be minus 10y. No, positive.
No, the direction, it's 20j. Okay? It's negative in front of the j. So either you do negative 2 times negative 2 minus 16, or what I did, I reversed the direction. When I do the j, I do 16 minus 2 times negative 2. So it will be 16 plus. So it's positive 20.
If you did the normal way, it'd be negative 20.